10 minutes.
Oh, wait.
So like, can we come back later if we don't finish?
No. It's not a hard test. And it's all multiple choice. So, I don't suggest you dilly dally and be late coming to class. Alright. So, how do we do shorthand notation? What do we need to do shorthand? The noble gas. Alright. Now, in order to do this, I'm going to give you a periodic table tomorrow. Alright. And what I will do, since tomorrow is club day, and we're going to have a shorter period than we normally have. Alright. When you get here tomorrow, I will already have everything laying on your desk. I will leave club day early, or I will do it before I go to my meeting. Since I don't have a club, I actually have to go to a meeting during club day. I will have everything laying on your desk. So when you get here tomorrow, all you're going to have to do is literally set your stuff down and pull out your pencil. Okay? If you need a calculator when you get here, go grab a calculator. I don't want anybody to claim they couldn't do 2n squared or count your electrons because I didn't give you a calculator. So get a calculator. But I will have your periodic table for you to write on there. You'll need your blue charts if you haven't written on them. If you've written notes all over your blue charts, you're going to need to get some from me. I will walk around tomorrow and check your blue charts, okay? Just because I have a problem with cheating. So I will be walking around doing that. Jade, put your phone on my desk for me, please.
Do not start with me today. Don't start with me.
Pack your stuff up. Yes, ma'am. This is Miss Wall. I have a young lady with a phone who doesn't want to give it to me. Thank you. All right. So when you have your periodic table, you put your numbers on it. So where the numbers need to go on the side. Okay. So when you have your periodic table tomorrow, put your numbers there. Where do the numbers start here? And here? And here. Now, if you want to use the arrow chart, draw it on the back, or if you want scrap paper tomorrow, get outline notebook paper, and that'll be fine too. Not a problem with that. All right? So, what element did I ask for? What element did I ask you to do in the opening? OS. All right. So, you said use a noble gas. Jaden did. So, what noble gas comes before osmium? Xe. All right. So, Xe. Now, when we took the quiz before break, this is too wide, I think. All right. So, this is Xe. So, when we did this before the break, about half of us got both of these wrong on the quiz. All right. Some of us got it wrong because of the numbering here. Some of us got it wrong because of the noble gas there. So, is everybody okay with how we chose the noble gas? Yes? Because remember, when I did the 4 answers on the test, I made the same mistakes y'all made on the quiz. Okay? So a lot of you are going to find an answer on the test. So we have Xe. Now, from there, what number do we have? 6. And then what block is this? That's the S block. So 6S. How many elements do we have? 2. And then what? 5D. How many? 1. And then we go where once we get here? We go down. And what do we have? 4F. And then how many? All the way across is 4F14. When we get there, where do we go? Back up to here. And we have how many? 1, 2, 3, 4, 5. Now, are we going to write 5D5 right there? No. Now, like I told you, you could just count 1 plus 5 is 6. Now, some of you wanted to say 1, 2, 3, 4, 5, 6 and write 5D6. There's not a problem with doing that as long as you remember to include what? The 4F14. And some of you are good about doing that. That's not a problem. Now, the biggest mistakes that were made when we took this quiz were the numbers that went here. Those coefficients were where we had an issue. Okay? You can't put those numbers in the wrong place. Now, some people wrote 4F14 and then 5D1. Not a problem with that. I had one person put them in numerical order and do 4F, 5D, and 6S2. That was fine also, but you can't have 6S2, 6D6, and I can't remember. Some people had like 5F14 or something. I wanted you to wait on an administrator to come get you.
You told me to pack my stuff up.
Exactly, so you were ready when they got here. All right, questions? Any questions about that one?
No.
Okay, so if we look at number 2, how many dots are there in the dot diagram for SE? SE has how many dots? Well, I got 2 voices out there out of 18 people. Okay, so there's 6. How do we know dot diagrams tomorrow on the test? How do we know the dots?
Look at
Highest.
Okay.
Like if you have,
All right.
is it electron?
Artificial electrons, what were you going to say?
The highest energy level.
Okay, the highest energy level. Okay, both answers are right. There's no one way to do this.
You should be looking like.
No, I was waiting for you to tell me what you were going to say. There are multiple ways to do this, okay? Some of you probably said the configuration for SE is what? AR, 4S2, 3D10, 4P4. Anybody draw the configuration? Nobody drew it?
Yeah, I drew it.
I would imagine some people in here actually drew it. Nothing wrong with that. Some of you said 4, 4, 6 electrons. Okay? Some of you looked at the periodic table and said SE is here. 1, 2, 3, 4, 5, 6 electrons. Some of y'all did that.
Yeah.
I got a couple there.
Yeah.
How'd the rest of y'all do it?
Wait, what'd you say?
Those are usually the 2 most common ways to do it.
Do the arrow.
You drew the arrows.
But that's the way to do it.
That is a way to do it. All right? Because the second part said, how many are unpaired? Okay, how are we going to figure out how many are unpaired? Okay, most people would probably draw the arrows. Not everybody, but most people would probably say 4P has how many arrows? It has how many?
4.
So 1, 2, 3, 4. So how many are unpaired? 2. Now, some of you see that in your head and wouldn't need to draw it at all. But if you can't see that in your head, draw it.
Well, okay. So on the. Never mind. You said it was multiple choice.
It is multiple choice.
Okay, now I was just gonna say on the test, will you accept rent, like the picture or the actual answer?
You have to pick the multiple choice A, B, C, or D. Some of them may even have E because my bubble sheet does A through E. Okay? Number 3. How many unfilled orbitals are there in vanadium? Okay? How would you figure out unfilled?
Well, you draw the
Arrow.
You could draw the arrows. That would be fine. What else could you do? Okay? Those of you who recognize the pattern on the periodic table may be able to do it in your head. Okay? Anybody able to do that? Okay? It is not 7.
Oh, darn. I thought I was 2. It's 2. No.
All right? It is 2. Now, if you look at vanadium, all right, the easiest thing to do anytime they ask about orbitals is to draw shorthand. All right? So vanadium has AR, 4S2, 3D3. Now, you know everything up to the end is always going to be what? This is full. 4S2 is what? So these are never going to be half full or empty. You don't have to worry about those. Those are full. So the only one we're concerned about is which one? 3D. Okay? So 3D has how many lines? All right. So how many arrows am I putting on? So how many are empty? 2 are empty. All right. Number 4. if an electron goes from 4 to 1, what is emitted? Or what would you need to look at?
Ms. Wall,
Yes, ma'am.
can I get some water for Jay, please?
I'll send the review sheets down in just a moment, Miss Moore.
Okay, thank you.
Welcome. All right. If an electron goes from 4 to 1, what is emitted? What kind of energy? I need something a little more specific. What? UV light. Okay. Now, the only right answer there would be UV light. So, if you look at your blue Bohr model, okay, 4 to 1, everybody looking at that model and understand where that answer came from. This one does not show a color, okay? If I asked you what color, you can't give me a color here because it's not in the color range. Does everybody see where 4 to 1 is on that wheel? On that Bohr model? That number goes down into what range? It's in the UV range, okay? So the only thing you can tell me there is it's UV light. Is everybody okay with that?
Yes.
Yes? No?
Yeah.
Okay. So the last one, what's the value of the P sublevel? It's 1. S is equal to 0, P is equal to 1, D is equal to 2, and F is equal to 3. Those are their L values, okay? That's the L value of the sublevel. Questions about anything I put on the board? Okay, that's just sort of a smattering of things we did before break. Yes, sir. Yes, you may. All right. Now, if you will, we were working on a sheet before break that applied the quantum numbers. Did we do question 13 before the break? I cannot remember.
I don't even know what paper. Was it that Thursday?
Yes.
The lab?
No, it was Wednesday. We did not do anything on Thursday but the lab. It looked like this. I can't remember if we did question 13. Yeah, find the one that looks like this. We did it on Wednesday. It says apply the quantum numbers. Okay, question 13 is a good one to do to bring us back into the fold. And then we're going to do some review. Well, I don't have any more. And Ms. Bowers is running a test, so you better find it. It says apply quantum numbers. We did question 44 and 45 in class. I want to work on question 13. And then we're going to practice, do a little review. And then we're going to and then we're going to do some new stuff. Just go can. We're going to. But I only need about 15 to 20 minutes for new stuff. Yes, ma'am. Were you not here Thursday? Okay. Or sorry, Wednesday. We were done this Wednesday. We're only going to take about 10 minutes. Answer as many as you can. We probably won't even take 10 minutes. Mark the attendance. Yeah. Everybody was here.
I do, and I try to make them as interesting as possible. Like, these I make really interesting. No, it's hard. Because if you want to go too fast. And I like to organize my notes in a way that it can study.
Oh, I know.
Here. Oh.
Yeah. You go there.
Are y'all done over there at the front?
I'm trying to understand it. You've been gone for so long. I tried to review. The day after you left, I forgot.
Yeah.
Yeah?
I was about it.
If you want to use all of
I
them.
didn't say that.
Which one, Justice?
I did my.
I said that, yeah.
I looked at my notes the other day. I did. I got it in my bag. I put it in there.
Would you stop? Either look at what you're doing or just be quiet.
They talking too.
I'm aware.
You can't.
If you turn around and be quiet, and they're still talking, I'm gonna yell at them next.
One person over here.
I don't mind yelling at smart people. Although why you would imply they're smart and you're dumb, I don't understand.
Because I'm not that smart.
Yeah. Oh, yeah, I was wondering about that.
Because helium is one.
What?
No.
This- Yeah.
Oh, yeah.
I love it.
Versus receipt,
The same thing.
there's two things.
Yeah, I thought you were saying the same. Because even Bowers is still making test copies back there. That or just don't write on this copy.
I'll just not write on it.
Exactly like that.
Actually, no.
D,
It might be.
D.
Yeah.
Element, there might be these types of two and a half, so this one would have 3 before that one.
I really don't care.
The first two.
Oh. Yeah.
No, but wouldn't it be? Which one was it? Would it be SC?
Yeah, that's.
Oh, that's what y'all phone us?
That's C.
Yeah.
I didn't know y'all saying that. See?
Remember that law found us?
Okay.
Sorry, artist.
First element in the pair of electrons in
That was it.
All right, how are we coming?
Good.
Good.
Uploaded the answers to the website now. All right. Find a periodic table. And that, and that. Pull that up. All right, so if we look at the first question. All right, the number of electrons in the outer shell of bromine should have been pretty easy. How many electrons are in the outer shell of bromine? 7. If you're struggling with that, which some of you may have been. 1, 2, 3, 4, 5, 6, 7, 8. Bromine would have 7. Is that okay for those of us who are like Xavier, who are like, I forgot it the day I walked out of class? Okay. B, the atom with an outer shell configuration of 3D10, 4s2, 4p4. Even that's in numerical order. It should still be okay. 4p4 ends on where? 4 is here. This is your P block. P1, P2, P3, P4 makes you who? Se. All right. 3 or C, the element containing the first D electron would be who? Sc. Now, D is a little harder. The first element to contain a pair of electrons in the D orbital. Fe. Okay? Now, to pair, you'd have to have how many electrons in D? 6. Remember, the D sublevel has 5 lines, right? First electron, second electron, third, fourth, fifth, and then which one will pair? Number 6, right? So D1, D2, D3, D4, D5, and then D6. So iron is D6. All right, E should be pretty easy too. The element for which the electron dot symbol contains 5 dots, and it's in the 5th main energy level. Now, 5 dots would be in which group? 5?
Wait, oh, my bad.
I said which group? All right. Group would be which group number? 5 dots. Okay. Now, the reason I point that out, okay, group would be group 15, and it has 5 electrons, right? So which 2 answers will be answer choices on the test tomorrow? 15 and what else? And 5. Both of those answers will be answer choices, okay? Because 5 electrons and group 15, people will choose what? They will choose 5 even though it's in group 15, okay? So if I ask you something as simple as what group is phosphorus in, people will count over and go 1, 2, boom, 5 outer shell electrons. They will mistakenly pick group what? 5, even though they know it's in group what? 15. Don't let me get you with something easy like that, okay? Now, so we know it's in this column. Now, what does it mean by 5th main energy level? It means the period, right? Does everybody remember 5th main energy level means 5th period? Okay? So, 1, 2, 3, 4, 5 means which one?
SB.
SB. A full 4th main energy level has how many electrons? 32. You remember the way to do that? I showed you a couple different ways before break. You can add what all together? Which way? Of each level. So which way did you do it? Okay, I showed you how to do it with a periodic table by adding all the places that had what together? all the places that had the 4s. So you could add this 4, this 4, this 4, and this 4 is one way I showed you before the break. You could add 2n squared and say 4 squared is 16 times 2. Or you could have said n equals 4 would have how many sublevels? 4 sublevels. What are their names?
S, C, D, and
And S would have how many electrons?
F. 2,
And P would have,
6,
and F would have, or 10, and then F would have, and then you would add them all up. And either way you use, you would still end up with what? Okay? All of those ways we've learned to find the answer.
Did you say 42?
No, I think it just sounded that way. So the first element to have an F electron would be who? CE. H. H sounds really weird. It's a really poorly worded question. The answer is bromine. I would not ask you something that poorly worded. But they're basically asking you which element has the same S and P electron configuration and it has the same energy level as fluorine. Well, it's in the same group, but has the same S and P configuration. I. So among the elements given, which one has the same dot symbol with 2 dots? Or sorry, which one does not have a dot symbol with 2 dots? Who does not have a dot symbol with 2 dots? How do you figure it out? All right, where is BA?
Somewhere. It's in group period 6. It's in group 2.
BA is here, so how many dots does it have? It has 2. All right, PB is here. How many dots does it have? It has 4 dots. So will it have 2 electrons or 2 dots? That's your answer. All right, PB. If we keep going, CA is here. How many dots will it have? It'll have 2. ZN is here. How many will it have? It'll have 2 because all of the transitions have 2. And then the last one is SR, so we'll have how many? It'll have 2. So the only one that doesn't have 2 is who? PB. Because it has 4.
Oh, I thought I meant like.
Yeah, it was asking who does not have 2. All right, the total number of orbitals filled in chlorine. The only way you can find total orbitals filled is to draw the what?
Orbit.
For the most part, unless you can shortcut it using the periodic table. Most of you probably can't. So chlorine has what? 17 electrons?
Yeah.
So 1s, 2s, 2p, 3s, 3p. So how many are filled? 1, 2, 3, 4, 5, 6, 7, 8. Why did I not count that one? It's not filled. So there are 8 that are filled. The number of half-filled orbitals of cobalt. What would we need to look for? Ones with 1 arrow. There would be 3. The number of electron-containing orbitals in bromine. Would I have to be full, half-filled, or would it not matter if it says electron-containing orbitals? Would not matter. So there are 18. The 6th period element with the same outer shell configuration as antimony is who? Because when you draw the configuration, the number of lines that have arrows on it is 18. You want me to draw it? I mean, I'll just keep going from where we're at. The one we were just talking about, yes, do BI. So that's what? 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Because that's BR right there, Justice. There's 18 lines there for bromine. And everybody's full except the last one, but it didn't say full. It just said contained electrons, which is why it's 18. All right, so M, those of you who yelled at BI, yes. The 6th period element with the same configuration as bromine is, sorry, wrong one, as SB is BI. Everybody okay with that? So if I go back, SB is here. That's in the 5th period. So the 6th period, same one would be, oops, get out of the way. Same one would be BI. All right, and the last question, the element with exactly 19 filled orbitals is who? Yes. Anybody have a shortcut way to do that? The element with 19 filled orbitals is? I'd say 19 times 2 also, because orbitals can have how many electrons? 2. 19 times 2 is 38, who has 38 electrons on the periodic table. That's how you do it. Okay, questions? All right, I have 3 review sheets for you because I just haven't given them to you. That's the only reason they're review sheets. They're a sampling of things you should be able to do. All right? Now, I'm going to give these to you for you to hand out because...
And make sure everybody.
That's right. And don't forget yourself. We're all grouped together. The premise is that since y'all are all right here, you won't forget each other. That's the premise.
I'm coming back.
That's what
I don't know why you're scared. Because I'm going this way. That's why.
We're not going to have enough time to do 3 full sheets.
Anything's possible.
Well, I'm not going to give you enough time, most likely. So, some of you may, I'm sure.
Oh, no, not with this one.
So, I have uploaded the answers to the website. Those of you who wish to study and check your answers, and there's some of you who will, have no fear, the answers are on the website. So you can check yourself tonight. You got it?
Yeah.
Did everybody get 3 papers? Now, if you will, I want to do one together first. Find one that has a picture of the puzzle on the back side. Got a picture of a periodic table with some letters. Okay, I want to do that one together first. Okay? So flip to that one. We're going to do it. I'm going to give you about 3-4 minutes. Read the questions. Each letter is only used 1 time. Okay? Answer that. Then we're going to go over it. Then I'll let you pick the one you want to do.
So we gotta fill in all of them?
Yeah, all 10 questions match one of those letters. No letter is used more than 1 time.
What? So we're, okay, so it says and.
Alkaline metal.
So we only choose one.
You can only choose one. One of those is an alkaline metal, but not the other. So choose the one that is an alkaline metal. Based on its position.
Use the letters, right?
Yes, I or C. Or F or E or J or B, whichever one you says is an alkaline metal.
Okay.
You with me now?
I was still confused. I was like, I don't get this. I thought these, you talking about these were the
No.
letters for the periodics. I was
No.
confused.
Okay, and these letters match up with real elements. Okay.
Yeah, I can. No. You answer these questions using these letters.
Like, for
Oh, okay.
example, this is an alkaline metal, which one of these is an alkaline metal?
Which letter?
And then you choose that letter and put it on the line.
It's obviously the I, because I is helium, that's a gap.
Alright, we done?
No.
Yeah.
Give me a second.
Okay, I'll give you a second, since you
A
have trouble
couple
with the
more
instructions.
sentences.
About the questions or about how to answer them?
If I get anything wrong on your test, it's their directions.
I will try not to hold that against you.
I
Or,
just-
let me say this, so tomorrow when you're taking the test, if you have questions about the directions, come ask. I will be glad to clarify directions, okay? I won't help you with how to do content, but if you're struggling with directions, I will be glad to clarify directions. Because I don't want you to get the answers wrong because you didn't understand what I was asking. All right, have we answered all 10?
Metal, I mean, and
Say we
remember
go.
metal mean metal? Does.
I have a.
One of those two. All right, so if we look at what you came up with. All right, let me get one so I know what the questions are. Was on this computer 6 second.
Oh.
All right, so an alkaline metal, which one?
See,
Why don't we pick I?
because.
Yes.
It's where I is, or where hydrogen is, right? Where I is. Where hydrogen is, and we know hydrogen is what?
Yeah.
It's a gas, very good. All right, an alkaline earth metal would be F. So an inactive gas.
Is that all we have?
All right, why do we pick A?
Oh, no, it's only gas.
They don't react.
Well, H is a gas and I is a gas, so why didn't we pick one of them? Oh, so is G. I, G, and H are all gases.
But no, gases don't really.
That's why we picked it, it's a noble gas, okay? That's why it's an inactive gas, it's a noble gas. Noble gases are inactive. All right, so an active non-metal, that's your H. Active is reactive, so a reactive non-metal is H. All right, a semi-metal. Okay, metalloids are semi-metals. An intertransition metal, or element, is D. Its most common oxidation state is -2. Okay? A metal with an oxidation number of +3.
E.
E. Why would we pick E?
Because if you look at your blue chart or whatever, it says oxidation.
The oxidation numbers
And
vary.
it's only metal.
What's the oxidation numbers vary, which is why we should pick E, because will you get an oxidation number chart on the test tomorrow? No. All right, and its oxidation numbers are +1 and -1. It's
Not right.
I. Now, you know I is a +1 because that's hydrogen and it's in group 1, but you do not know it's -1 and you don't have to worry about that. Number 9, a +3 oxidation number for a metal. Oops, sorry,
Miss number 8.
I missed number 8.
I was about to say,
I answered a metal with more than one oxidation number was E, but I was babbling on about 9. A metal with more than one oxidation number was E, and then a metal with an oxidation number +3 would be what? J, because it's in group 13.
so F is intermetals?
F is, where are you at?
No, I mean,
F is number 2.
F is number 2, it's an alkaline earth
I'm
metal.
at F.
F block is D, the intertransition metals, yeah. Because they were cut out of the transition elements. Those are the lanthanides and the actinides, and they're also called the inner earth metals. What's the other name for, did I tell you the other name for the lanthanides? They're called the rare earth elements. Typically I do that when I teach the new part of today, but they're the rare earth elements. All right. Let's see. Let's do the Kahoot first, and then I'll give you time to work on that before we do the new stuff. The laptop card is unlocked.
Yes, excuse I think you charge them $50.
Huh?
Why did you charge them? Why did you do
All right, we're up to 16. We should have one more. Who am I missing? There we go. All right, this one's pretty long. This one has 20 questions on it. It's one of the longest ones I have.
The I value of the piece of
The L value is.
Oh, how do I do this? Oh, I think.
I can't until Everybody answers.
Yes.
All right. Y'all should have known that. It was in the opening. What was the L value of the P sublevel in the opening? It was 1. S was 0. P was 1. D was 2. F would have been 3.
You got it right.
I'll be like
Oh no! I can't believe y'all don't have a periodic table. You might even use a blue chart. So while y'all are scrounging, make sure your blue chart's handy. No, the one that's got Moore's model on it. You don't need your oxidation sheet tomorrow. All right, so before I advance it or move to the next question, okay? The outer shell electrons for sulfur count 1 to 8, so sulfur should have 6 electrons. The -2 that people picked was the what? The oxidation number. Now, if you want your periodic tables out, get your periodic tables out. Okay, you may have the one that's orange that has the numbers, which is a good idea.
Yeah.
You may have both that you color coded for today, which is fine. These are practice. I don't care if you're using your notes today. And you need your stapled blue chart, so if I give you a Bohr question, you have it. I haven't used this in 6 months. I don't remember what's in this review. Okay, I remember third period because we're doing it now. So there could be a Bohr question in here that needs you to use your Bohr model. So have it handy. Okay. How many electrons are in the third highest main energy level?
Oh.
I feel like I'm
All right. I ain't too hot. Unless someone's got it right and got it wrong. All right. So if you look at the third highest main energy level, what does third highest main energy level mean?
3 was enemy.
Okay, it means n equals 3. Okay, third, it means the outer shell. Or the. So, if we're talking about the third ring, how many sublevels are in the third ring?
3.
3. What are their names?
S.
How many electrons are in S?
2.
In P?
10.
In P was 6, and in D was 10. So if you got 2 plus 6 plus 10, you get
18.
Okay. All right. Which quantum number describes orientation in space? There's only 4. All 4 of them will be the 4 answer choices. I won't make up any junk answers tomorrow. Those will be the 4 answers. All right. The person who picks spin, what does spin tell? The way the electron spins. Okay. Principle tells what 2 things? Size and the energy level, so at least everybody pick that one. All right, so we're stuck between orbital and magnetic. Orbital tells what? Sublevel and shape. So magnetic tells either you could say orientation in space, which is what I said, or tomorrow on the test I might say the number of orbitals. I can also use the definition number of orbitals. Okay, which color of light is emitted when an electron goes from 6 to 2? Yes. Dear God. I only have, I think it's 18 and only 4 are F's. 14 are G's. How many is that? and 3 of them are 58, 59, and 59.
That's so sad.
What? Yeah, that is sad. Those are her Saturday school contracts. I only had 18, and 14 were D's.
Only 18, that's a lot.
Out of how many?
3 classes.
19.
Oh.
The vast majority of my D's are like 67 and above.
Go ahead, Tony.
I'm so glad we're not used to it. 44.
I take it back, I might have 5 F's.
You what?
I think I had 5 F's. I had 1 in chemistry, and I think there were 4 in physical science.
Are you ready? Oh, you got me set.
How Plumber just D's? She been trying to show it off all morning. That or you might want to back up to that paycheck.
I would be doing the same thing.
What is this, not 50? How many kids you teach a day?
Hey, so I'd do the same thing if I had.
I would have 23 and 25.
That's
like third grade honors. Yeah, 19 kids.
Dang.
Yeah.
All right. So the 2 people who picked green and red. All right. When you go 6 to 2, the number you get is 410. All right. Did y'all not use the chart? The 2 people who picked it or get the wrong and touched the wrong number, or did you really not know what you were doing?
I see what I did wrong now.
Okay.
I saw 410, and I thought 4.10 is the 4.10. I see what I did.
Stop.
No, I thought 40. What did I think?
It doesn't matter. You know what you did wrong.
Yeah.
To fix it for tomorrow.
Yeah.
Okay.
I was in a rush. Okay?
All right. That's all right as long as you know how to fix it. All right. So the relationship between wavelength and frequency. Because there's only 3 answers, so it's stretched across. Anybody remember which one's directly proportional? No. Energy and frequency. Okay? Yes, you did. You're either really good at memory or you did study. Energy and frequency, E equals HV. So energy and frequency are directly, and wavelength and frequency are inversely. Nothing is equal. At least nobody picked that. Which 4th period element has an octet? And who is Sam, by the way?
Me.
Oh, okay. I didn't realize you shortened it. Okay. Makes sense now that you say it.
Oh, shoot. Oh, shoot.
Dang. Y'all tell me I've got a bunch of wrong answers here.
Yeah, you definitely.
Oh, my God. Yeah, you did. Sorry. The wrong one. Miss Wallback.
Apparently, actually, Tiffany and Darlene taking the test together.
Oh,
Y'all are
shoot.
like 2 brains over there comparing answers all the time.
Yeah, I forgot to read them.
Well, at least it's not too bad. We didn't get 12 who got it right. Remember, 4th period. Which one do you start counting at? Helium's at the top, right?
Hey.
So 1, 2, 3, 4. Krypton. Okay?
Yeah, sure.
Yeah, sure.
Yeah, sure. Yeah, come on in. Yeah, sure.
All right, what's the M value of the P sublevel? M value of the P sublevel.
What do we think?
Click. Oh, mine's mine. I got brown.
It's not too bad. All right. The one, I don't know what they picked up for. -2 to +2 would be assuming that the L value was 2, and that would be D, not P. So that's why it's not the green. If L equals 2, what's N?
Oh, gosh. Oh.
So, what's the key to getting that question right on the test
N
tomorrow?
is always one above.
N is always one above. Okay, so if you forget, remember the rule. N is always one more. So add 1 and you'll get 3.
Yes.
Now, the reason for it though is L equals 2 would be what sublevel? S is 0, P is 1, D is what?
D.
2, right? So S, P, D, N would have to be what? 3. You can't have a D sublevel unless you have D. Or 3. All right, how many unpaired electrons are there in sulfur?
47.
47, really? Y'all are smarter than that on the test. We're in trouble.
I took a guess.
Oh.
Oh! I got it right.
Oh,
Dang,
I got it wrong.
All right. Remember, sulfur ends on 3p4. So if it ends on 3p4, there's 3 lines. 1, 2, 3, 4. 7 are unpaired. 2. All right. How many electrons can the F sublevel hold?
No, we're gonna try.
Oh.
You took the sound off.
Did I?
Yeah.
You know, make no kind of noise.
Oh, wow.
Oh my God.
Yeah.
But
I didn't hit anything. I know of.
the sound went off.
I don't know.
Catch up.
It's not muted.
You go catch somebody.
Oh, stop.
Oh.
It's not muted up here either. Because that's mute. I didn't do anything to the sound.
You know, bro.
I don't know what happened to the sound other than I didn't touch it. See, there's sound, but I didn't do anything to it. I didn't do anything to make it come back. All right, lowest frequency. Do we look for high or long wavelength or low wavelength? All right. Lowest frequency is the longest wavelength. Who has the longest wavelength? Radio waves. Remember, they're opposites or inversely proportional. So radio waves. Okay? All right. How many electron-containing orbitals are there in magnesium? Electron-containing orbitals. It's number 12.
Thank you.
You're welcome. I don't want you looking for days.
Really?
Oh, never mind. It's just asking for
Alright. So it says electron-containing orbitals, right? The only way you could know is to do what? For most of them, a lot of you could draw, or it said electron-containing orbitals. How many electrons does it have? 12. Every orbital contains how many? 12 divided by 2 is? That's the short way. Or, for most of you, you could have chosen to draw it out, because it just says you got to contain the electrons. It doesn't say it has to be full, right? So 1, 2, 3, 4, 5, 6. You didn't have to. That's why I gave you the shortcut way first. It had 12 divided by 2 electrons was how many? 12 divided by 2 is 6. That was the shortcut. That should be an easy one.
Oh, I didn't even click it.
10 months with university.
It doesn't fall from my chair.
No, I didn't.
Alright. 4 of us didn't get it. Alright, so 4s2, 3d5. 4s2 would put us here at potassium, right? So 4s2, 3d5. 1, 2, 3, 4, 5. We okay with counting across 3d5? Does that make sense?
Yeah.
Okay. I would have thought that would have been 100. Really not. Iron would be 3d6.
Oh, my favorite. Where is
Tellurium's 52, I think. Yeah.
Oh, Jesus. Come on.
So now that I told you it's 52, we should be able to do this in less than 60 seconds.
Well,
A lot of the time is built in, given you don't know where the elements are. We have 17 answers. Why is it not ending?
What does it say? We got 8.
I thought we had.
Oh, 18. All right. So, 4,
Oh, wow.
8. Outer shell electrons. And now that's where dots. Dots are outer shell electrons. 1, 2, 3, 4, 5, 6. Okay? 8 would be group 18. And group 14 would be 4. I don't even know what to say to that at this point. Y'all should not be missing that kind of question. How many electrons are in phosphorus?
31.
P. It's on the right hand side above the staircase.
Group 15.
Number 15 on the table.
I got it.
right. The people who picked 5 in blue, what's the 5? It's outer shell electrons. And it said total electrons. Total electrons is not outer shell electrons. The person who picked -3 picked the what? The oxidation number. All right, oxidation number and outer shell electrons are not the same thing. Okay?
Where's silver?
Highest main energy level in silver.
What is silver?
AG, it's number 47.
Oh, man. Yes.
All right, that's an interesting spread. All right, what's the highest main energy level mean?
The period.
Okay, period's one answer that would be great. Okay, but it essentially means the what?
Outer.
Say it. Outer.
Shell.
Exactly. Outer shell. That's simple. Couple different ways you can do it. You can either look at the period or you can find the outer shell. So some people might have written the configuration for silver, which would be Kr 5s2 4d9. So the period or the highest energy level would be a what? 5. Or you can look up here and you can say, okay, it's in period 1, 2, 3, 4, 5. Period 5. Either way would work. Okay? But the highest main energy level right here means outer shell or period. Does that make sense? Either one works. But that's a terrible spread right there with only 8 people getting that question right.
Most reactive
Most reactive non-metal. We did this Wednesday before break. It's coming up for real. I'm going to talk about it. Oh, all right. That sucks too. All right. So, how do we decide? First of all, at least the 8 and 8 split are at least both non-metals. The 2 people who picked sodium and calcium, y'all picked metals. Okay? So the question said non-metal. So these 2 answers are metals. Those can't be the answers. These 2 are at least non-metals, so that's good. Now, which 2 groups on the periodic table did we say were the H's? 2? 1. So those would be the most reactive metals. So Na would be the most reactive metal. But that's a metal, so that's not the answer. So, who is the most reactive non-metal? Fluorine, or F, because it is the group that's how many electrons away from having 8? 1. It has 7 electrons. It will take an electron from anybody. So group 1 is the most reactive metals. Group 17 is the most reactive non-metal. So fluorine is the answer. O would be the next most reactive group. All right, which element is the most stable? Most stable.
How do you determine if it's most stable?
You got to get one with the same discussion.
Oh, Oh, shoot.
You just take a long.
Oh.
Get it right.
Ah. Where's Casey?
Hey, right here.
K is in group 1. ZN is in the D block. Number 30. Potassium's 19. Chlorine's 17. Xenon is 54.
I think I'm wrong. I have a big one.
All right.
Oh, yeah.
The 10 of you who said xenon, why would it be the most stable? It's got 8 electrons in its outer shell. It doesn't want to take. It does not want to take one or give one away. It has 8. It is perfectly content with its 8 electrons. Okay? The rest of them all need to lose one, gain one, or something to get to 8. Okay? Remember, it's all about 8 electrons. All right. Last question. It should be an easy one. Who's a lanthanide?
Ooh, I know that one.
Yes.
That's my name.
I'm gonna say long.
Yeah, this one should be easy for you.
There we go.
No.
All right. So, the one person who thinks Seaborgium, I just don't think looked at the periodic table and said, take a whirl and guess. Because it's not even in the actinides, it's a transition element. Okay? Questions? All right. So, scoring people are.
I really got 19 out of 20 because I accidentally clicked one before.
So you didn't get 19 out of 20. You either right or you wrong.
It says you got 18.
Yes or no?
All right. Now, if you have a laptop, put it up. All right. If you don't have a laptop, put your phones away. Okay. I'd really prefer to avoid another scene like we've already had. So, given the time that we have, I need to talk about Mendeleev and the periodic table. So, I have provided you with a couple different forms of review today. If you wish to work on the review sheets that I've given you to try to practice some more before the test, the review sheets, again, the answer keys are uploaded to the school website. Those of you who've never been to the school website or my website, I don't know what to tell you at this point. Okay? Go to the school website, go to staff, go to science. You can find me, and you can click on our website. Sure. And you can see the answer keys. Ask your classmates, and I'm sure they can direct you. Okay? But all 3 answer keys are there so that you can check your answers to the review sheet if you would like to study. Gentlemen, pick up the pace back there. Okay? Now, we're going to spend the last 20 minutes talking a little bit and introing the next unit, which you'll be shocked to know is on the periodic table. All right. However, rather than including it with this topic, we need a breaking point in a test because if not, then the test just gets longer and longer. Because at this point, we have 65 questions already, and I just can't make the testing longer. Yes. Can you go to the restroom? I don't care. Have you used any of your whole passes yet?
Yeah.
All right, so, yep, I'll leave you one.
We only have 70 minutes in here, right, tomorrow?
Yes.
That's a minute.
Yes. Like I said, and I'll put everything out on your desk. So when you get here, it's plenty of time. Most people finish the test well under that time. Okay. There have been years that we've had time to go on and do something else after the test. But some years we have slower test takers who eat up the whole time. So if you need the whole time, that's fine. Okay. Yes. But sometimes I think you just hold the test so I can't go on and teach something else. I don't think it's really I can't finish the test. And I know that. Okay. I'm not going to hold it against you. All right. But don't think I'm going to give you extended time into third period either because you're not done with the test either.
I'm very well.
I know. I know.
You're very well. I'm good.
So, typically the next test is the one that causes us the greatest difficulty. And the biggest reason for that is because it's a long test. It's about 78 questions. I'm actually contemplating this semester breaking it into 2 tests. I haven't decided yet though. And it's on the periodic table and on bonding. We're going to start with the periodic table. Now, the lab report is due Wednesday. So, for those of us who are here on Thursday before break, which is about, I think, 12 or 13 of us, the lab report is due Wednesday. If you are here and you don't turn it in to me on Wednesday, and yes, I will check the attendance when I grade it. If you are here and I didn't get it or don't get it, handwritten in black or blue ink, then it's minus 10 per day when you turn it in. So if you turn it in on Friday, that's minus how much?
But like the end of the day? On
No,
Wednesday?
that second period when I collected at the start of the
But
class
if we
period.
weren't here, then it's due whenever we come Wednesday after school.
So let's say you weren't here and you come Wednesday after school, yours would be, it's a very easy lab report to write. So
Okay.
yours would be due on Thursday. The only reason theirs was not due the very next day is because I wasn't going to make them write it over Easter break. Because I'll be honest with you, I didn't do any schoolwork until last night, and I did about, I don't know, 45 minutes worth of tops. That's only because I needed to prep for today. And then I wasn't going to make you not study for the test by writing a lab report. Otherwise, it would be due the very next day. Okay? So, if you come Wednesday, it would be due on Thursday. Now, and I will say this, any of you who can't stay Wednesday, have a ride home. And need or want to stay on Thursday because we get out early, because it does not take very long. I'm going to be here at 7. Or you want to go eat and come back to do it because I'm going to be here, you may do that. I realize there will be very few people who take me up on that. You may do that.
What if
Okay.
he can't come Wednesday? He wants to come during lunch.
It's real hard to do this one during lunch. How about next week?
Okay.
Okay. But Wednesday's really the only day I have this week. I have a doctor's appointment tomorrow, and then Thursday, of course, is parent conferences.
Friday?
Huh?
Friday?
Yeah, it's just a weird day to have parent conferences. I don't know why they put them where they did. All right, so we're going to talk about the periodic table. Dmitry Mendeleev is one of the few scientists that y'all actually have to know something about. When they redid the curriculum about, I don't know, it's probably been 6 years now, they took almost all of the history out of chemistry. There used to be a whole section of chemistry that had the history of the atom, who discovered the proton, the electrons, the neutrons, all of that we had to teach. All of the history, how they discovered the parts. They took all of that out of your curriculum. However, this is one of the few pieces they left in the curriculum, okay? Dmitry Mendeleev designed the first, No, it's his eye. Okay, Dmitry Mendeleev designed the first periodic table. He used index cards. Now, were these real index cards the way we know them? Probably not. Okay, I'll be honest. They were probably not index cards the way we use them. But for lack of another example that I can give you that you can relate to, we're just going to call them index cards, okay? He wrote all the info known about each element on the card. Okay? For example, he included atomic mass, which was all that was known at that time, density, oxidation numbers. Hold on, I'm going to show you what he had for his first periodic table here. I think this is what this is.
I know, Zoe asked, Zoe told me, she's like, what about you this week? And I said, okay. And she said, are you not playing? I said, no. No. I want to, but then again, I don't want to. I'm gonna golf.
Oh my God.
All right.
You can come to my golf thing.
Yeah, go watch golf. It's like watching paint dry.
I just hit the ball.
Okay, hers might be entertaining. All right, does everybody have what we need?
I'm not quiet, that's why.
Huh?
Think of it like, shh. That's the thing.
Do tennis we can.
No. Tennis. Yes.
All right, is everybody caught up? Everybody there except for Xavier?
We'll think about it. Yeah, Jake.
All right.
We'll discuss.
Now, while he was doing this, he noticed two patterns. Of course he did, right? Okay. One, most of the elements increased in atomic mass, but some went down. And number two, elements had similar properties. Okay, elements had similar properties. He placed those in groups or columns.
What year?
Mm-hmm.
What year?
This was really early.
The
1800s. Let me look. I'm not good with the dates. 1871.
The year you was born
He's holding up well for his age. I clearly found the Fountain of Youth somewhere.
Back in my day, Mr. Razzier, that's right.
Who says that?
Miss Long. She like back when I was a little girl.
She knows she
dinosaurs.
How old is she?
She is
This client's a few years older than I am.
60s.
Dang, she don't age.
She don't age. She don't age good.
All right. So now,
Me and Zoe couldn't figure it out. We thought we couldn't figure out if they were tattooed on or drawn on. It's okay. We'll have to do the.
what are y'all talking about now?
Eyebrows.
Let's talk about Miss Bowers' tattoo.
No, I brought
They're tattooed. Mendeleev.
She got her eyebrows tattooed.
Yes.
Wow.
No, she answered that. That's not the answer to the other question.
Why does it matter?
Yeah.
You're that old. Why are you concerned about this?
All right. Mendeleev couldn't explain. Mendeleev couldn't explain why mass went down in a few areas. Jaden, are you listening?
Yes, of course, I'm right.
Okay, do it without talking. Now, as an example to illustrate this, all right. Sony glasses. That's better. All right. So to illustrate his problem, okay, he said these two have similar properties. These two have similar properties. However, the mass goes down. According to Mendeleev, he believed mass should increase, but he had no explanation for the decrease. Well, hold on. We're going to talk about that for just a second on the next slide. Okay? So, the properties, he said, made him say, okay, SB and TE have similar properties. AS and SB have similar properties. So, those should go together. But the masses go down. Why do they go down? He had absolutely no idea why those masses went down. He could not explain it. But he thought the masses should go up. Most of the masses on his periodic table do go up. However, some of them go down. In about 3 or 4 spots, the masses do go down. Even if you check the modern periodic table that we're using, there are 3 or 4 spots where the masses go down. And this is one example that I'm using. Now, if dude has all of this going on here, if you look at SB, antimony to tellurium, the mass goes down 121.7, and then it drops to 126.9. It does not increase. It goes down.
Oh, wow.
The numbers get smaller. I don't know how else to say that. The numbers don't go up. They go down.
It's not going down.
I wrote the number down wrong then. It's supposed to. Oh, I wrote tellurium and iodine.
No.
That's where I'm at. I've been on the wrong one.
Yeah, I was like,
Hold on. Hold on. I wrote the wrong elements down. I gotta fix that. Sorry, for those of you who wrote in ink, wrote the wrong elements down. Yeah, you should be confused. Thank you very much.
Maybe that just made sense,
No.
but I didn't get it either.
Thank you very much for saying that.
That's why you don't write in ink in this class.
Very good. With me, you're correct. You should never write in ink.
That's why I can't copy her notes. I mean, I don't listen to my notes.
Does this make more sense, Tomas?
Yeah.
There you go. Thank you. I picked the wrong elements. That should make more sense. Now they go down.
They're happy with their wrong.
All right, now they go down. Now when I say they go down, the numbers really go down.
That makes more sense.
Yeah, I thought you were looking
Yeah, I was
backwards.
looking. I was like 121.
Yeah, I know. When you looked at that, and I looked up there, I was
I
like,
thought they would
you're right. They don't go down.
Errors, but you're for that.
No, they didn't go down.
I
You were
looked a
correct.
couple of times because I thought I was
Yeah,
wrong.
you're not wrong.
Good job.
Yeah, y'all were not wrong. When I looked back up there, I was like, no, they're not wrong. We need to fix that. All right, so why are we giving some dude who can't explain why his numbers don't go wrong credits 150 years later?
You wrote some stuff down.
He did write some stuff down.
There was a revelation.
There was, okay? He predicted.
You go back.
After all that, you still don't have it all down.
I'm still behind.
Stop writing down all that stuff you took pictures of. You can write that stuff down later. All right? He predicted the existence of elements not yet discovered. and their properties. So, I know this is hard to imagine, but picture some old guy with a large table and index cards. All he's got are index cards with information written on it. He's got all this spread out on a large table. He's trying to organize and make something into a table, sort of like what we have up there, but it's not anything like that at this point. And he's trying to put it into some type of order. And he's saying to himself, there have to be things missing. There's no way these are all the elements. They're going to be discovered someday. So he leaves a blank spot on his table and puts a question mark. And not only does he put a question mark there, he puts a mass out to the side and says, someday an element will be discovered, and it's going to have this mass. It's going to have these properties. And he puts in 3 or 4 more elements with that same concept. This element will be discovered, and it will have this mass. Now, what, Tomas? Yes, all of these elements, nope, were discovered, and all of his properties were correct. Now, because all of this was right, we sort of overlooked the fact that his mass was wrong, okay? He was never able to explain why mass did not always increase. Okay? He never knew the answer to that. Exactly. It just doesn't.
It just doesn't. That's wrong. Are we done now?
Not quite. Okay, it's just for you. The notes that I'm talking about right now, they're about 20 minutes worth, but most of the day we reviewed the test. We didn't do most of this in class. We put a questions and we talked about stuff. The answers are on the website. Okay, review, study for your test. Lab is due what day?
Wednesday.
Very good. Okay, so he was never able to explain why mass didn't go up. So why do we give this dude credit if he can't explain that piece? Because of all this. So, did he put these elements in the right place if mass didn't go up?
Yes.
Because he arranged it based on what? Similar properties. Now, when we come back together after the test tomorrow, so on Wednesday, can anybody tell me what was discovered to explain why these are in the right place?
A gap, missing element. I don't know.
Something we've learned this semester. The atomic